Okay, here we go. Section 4.9. Solve by graphing. But it's not the same graphing we're doing. So, here's what we do. Step number 1 in doing these type. Notice there's no y, it's now 0. So basically y is 0 in this case. But step number 1, find the x-intercepts first. What ways do you know how to find x-intercepts?
Completing the square.
Complete the square, quadratic, factoring, and then solving if you want to. But the easiest way for this type of problem is actually use your calculator. Okay, so everybody get out your calculator. Let's save some time because your answers can be in decimal form. So these answers, x-intercepts, make them approximate answers. I don't want this answer, 5 plus or minus square root of 2 over 7. I don't want that now. I want the approximation of that, okay? So you could do it by hand and do all that, but easiest, let's put it in the calculator. Put that quadratic 2x squared plus x minus 4 in your calculator. Go for it. 2x squared plus x minus 4. I'll put it in mine as well. 2x squared. Oops. Plus x minus 4. Hit the graph key. What are we going to be looking for?
Zeros.
The zeros. Remember all the different ways to say it? X-intercepts are zeros. So remember how to do that? I'm going to show you again. People forget the boundary stuff, so I want to make it very clear right now. Save you some time. Second, calculate up here. Hit number 2 for 0. Now, how do you do the left boundary, right boundary? Half the people know, half the people don't. So you have to focus on one of the points you want. Here's a 0 right here, which means I want to make a boundary to the left of it. So pick anything to the left of it. What number would you pick to the left of my point right here? Pick a number to the left. What? -3 would work. That's right here, right? -3 is right here. So type in -3, press enter. Look what it does. It gives a little arrow right here. That means starting here to somewhere else, it's going to find a 0. So you have to make a right boundary. That's what it's asking for now. Where is your right boundary? You pick one.
5.
Okay, now be careful. If you pick 5, which is over here, you have 2 points in the middle. You don't want 2 points. You want to be specific. You want to pick from here to here, and then it'll choose this one. Then when you do the other one, you want to pick from here to here, and it'll choose this one. You have to do one at a time. You understand?
Yes.
Okay, go ahead and get this one. Pick a right bound. What number would you put in?
0.
0. It'd be easy. 0, enter. Then it has guess. Notice my 2 little triangles. Between here and here, it wants you to pick a 0. Yes, guess. There it is. Notice how it blinks right on it. 0 is -1.686, blah, blah, blah. I want 2 decimal places. So therefore, my 0 is -1.69. I get some people who still aren't rounding correctly. Please understand how to round. Okay, I marked off a bunch of points for rounding errors. If I want 2 decimal places, you look at the next one, 6, which rounds the 8 up to a 9. Okay, write that one down. You go get the other one by yourself. Go. Get your zeros here. Get your other one. Make a boundary. So second, calculate 0. Pick a left boundary to the left of this one, which is 0. I'll pick 0 in this case. And notice it puts a mark right here. And then I'll make a mark to the right, which I don't care. 3, 4, 5, doesn't matter. 3, enter. Puts a triangle up here. Between here and here, it's going to pick a 0. It's going to land right there. Enter. 1.19 if I round correctly. Write those 2 numbers down on your paper. Here we go. So, number 1, I wrote it down, find the zeros. They were 1.19 and what? 0.69. Okay, those are my 2 zeros. Step number 2, put those zeros on a graph. So put those on a graph. So everybody draw a normal graph. Space it out a little bit. 1, 2, 3, 4. 1, 2, 3, 4. Just make it quick. What's nice about this question, these graphs do not have to be exact. You know your first question we did last time? Those graphs where you have to shade, I want those graphs to be exactly the way they're supposed to be. This graph right here is a sketch. Alright, so put those on a graph. Let's put negative 1.69 is somewhere around here. Put a dot. 1.19, about 1.2, somewhere right around here. Put a dot. Now, the next step, actually let's just put it under step 2. We'll say sketch the curve. Which means all you have to do is look at your calculator and say, actually you don't even have to look at your calculator. Is this thing going up or down? You can tell by the A. It's going up, right? All I have to do is this. I don't care if it's shorter, longer. If it's going up, just draw something like this. This is a sketch. Please don't go and get a bunch of coordinates and draw the coordinates in here, because it does not matter. Okay? We're using this to get our answer. Okay? Here we go. Sketch the curve. We did. Step number 3 is actually just interpret your results. Here's where people struggle, right here. Try to understand me when I do this, okay? Alright. Actually, I should do it on here because people are watching this. So, what does this say? This thing, when is this greater or equal to 0? Try to follow me here. This whole thing represents the curve, right? This thing represents this right here. So tell me this. When is this greater than 0? You know what I'm asking you? When is the function, when is the curve greater than 0? I'm going to highlight it for you. You see this? Basically it says, when is the curve above the x-axis? When is the curve positive? That's what this is saying. When is the curve positive? Right here, right? This is positive. All these y values are positive. And all these y values are positive. You understand what I'm saying? All those y values are positive. No, but that's not what the question's really asking. The question's asking you, what are the x values that make it positive? That's what the question's really asking. What are the x values that make it positive? Can you point to the x values that make it positive? What would make it this part right here? Which x values? These ones? These ones? These ones? Yeah. These x values would create positive answers. These x values would create positive answers. Now all you have to do is tell me what those answers are. What is this right here? X is greater than, because it's to the right, what? True, equal to 1.19. It's going this way, so this is a or. X is less than or equal to negative 1.69. This is why we have to name our x-intercepts. These actually are not called they are called x-intercepts. They're also called critical points. These are our critical points right here, our x-intercepts. Okay? So number one, find your critical points because those are going to be the ones in your answer right here, your critical points. This is the final answer. If x is greater than 1.19, if I put an x value greater than 1.19 in here, what do you think would happen? It would satisfy this inequality. It would make it greater than 0. If I put something in less than negative 1.69, guess what? It would make this greater than 0. This takes a couple for some people. Some people can get this right away and say, okay, I understand, I'm good. A lot of people, your thinking isn't inclined to this type of thinking here. You got to take a couple to do it. So, find your critical points, sketch your curve, up or down, and then just say, okay, when is it greater than 0? Oh, right here and right here, which means these are my x values, these are my x values. Put that right here. Let's do another one. Any questions before I make you do another one?